Hi, welcome to my capstone presentation. My name is Tabitha, and the title of the project that I'm presenting is called Forage Fish Distribution Across Tidal Elevations, Implications for Habitat Management. I'm going to get started with some background on this issue. Forage fish species such as surf smelt, which is pictured below, play an important role in the Puget Sound trophic web. They're an essential food source for ecologically and culturally important species like salmon, marine mammals, and birds, which makes forage fish a foundation species for many marine ecosystems. Existing research on surf smelt is pretty limited, but the studies that have been previously conducted suggest that surf smelt tend to spawn in the upper intertidal zones of shorelines. However, their preferred shoreline spawning habitat is being reduced over time by coastal squeeze, which is when a combination of sea level rise and shoreline armoring causes coastal habitat to be covered by rising tides, which can be very harmful for species that depend on that habitat for reproduction. This map shows DuPont Wharf on the Washington coast, which is where I collected samples for this project. The shaded areas depict projected sea level rise in 2050. As you can see, both survey stations that I collected samples from during this project will be affected by sea level rise in the future. Due to these combined issues and the importance of forage fish in the Puget Sound ecosystem, it's important that we get a better understanding of where on the shore spawning occurs so that their habitat can be better protected in the future. The research question that I chose to focus on for this project was, how is surf smelt spawning distributed across a gradient of tidal elevation at DuPont Wharf? I conducted this project while interning with the Nisqually Reach Nature Center, which is a nonprofit organization based in the Nisqually Reach that conducts multiple citizen science projects, including forage fish surveys. The purpose of this project is to collect sediment samples along set transects on the shore and examine them for presence of forage fish eggs, specifically surf smelt and Pacific sandlands. And then this data is sent to the Washington Department of Fish and Wildlife and the Department of Natural Resources to help inform land management. For my independent research project, I used tide data from an online tool that keeps track of tide information to mark 1 foot intervals of tidal elevation, and then I collected single scoop sediment samples at each interval. This image shows white flagging that I placed at each interval of tidal elevation at Station 1. I marked each foot between high and low tide, which resulted in a total of 10 samples. Next, I processed these samples following Washington Department of Fish and Wildlife guidelines, which included separating out the smaller sediment materials to condense the samples, and then examining them under a microscope to find forage fish eggs. Then I identified the species and developmental stages of the eggs that I found, and then used that data to determine trends in spawning distribution at each survey station. The results that I got during the study were fairly consistent with previous research that found that surf smelt spawning typically occurs in the upper intertidal zones. Previous literature suggested that surf smelt spawning typically occurs between 8 and 10 feet above mean lower low water, which is the baseline used to measure tidal elevation. In my data, I found that the greatest occurrences of eggs were higher on the beach than what was shown in previous research. In the first survey that I conducted, which was on January 14th at Station 1, I found eggs in each sample between 7 and 15 feet. In the second survey, which I conducted on February 10th at Station 2, I only found 1 egg each in the samples collected at 10 and 13 feet. Both of these eggs were dead, and I couldn't definitively determine their species, but based on where on the beach I found them, they're most likely surf smelt. I didn't find any Pacific sandlands eggs in my samples, though I did look for them as well. This graph shows the number of surf smelt eggs I found at each 1 foot interval of tidal elevation in my first set of samples, which was at Station 1. As you can see here, the highest numbers of eggs were in the samples collected at 8 feet and between 10 and 15 feet, with a peak at 12 feet above mean lower low water. For next steps for this project, a lot more research is necessary to confirm the patterns that I observed. Due to the time constraints of my internship, I was only able to conduct 2 trials, so my data is pretty limited. Part of future research should also look into other factors besides tidal elevation that could influence spawning distribution. This could include adverse weather conditions or human interference with spawning habitat. Future research should also focus more on Pacific sandlands because they're also an important forage fish in the Puget Sound ecosystem, and not much data is currently available about them. Another important next step would be increased monitoring of sea level rise in the Puget Sound region, so more accurate predictions of how habitat will be impacted in the future can be made. Then this data can be used to predict how forage fish populations, as well as other species in the ecosystem that depend on them, will be affected, and then that information can be used to help inform habitat management and policy decisions. I want to end this presentation by acknowledging some people who contributed to my project. I want to thank my site supervisor, Terrence Lee, and the rest of the Forage Fish Survey team, including Sierra, who also conducted her capstone internship with the Nisqually Reach Nature Center. I also want to thank my faculty advisor, Jason Toft, the rest of my capstone cohort, and my family and friends who supported me throughout this project. Thank you for listening to my presentation.